Hi, welcome to my video on graphing exponential functions by transformations, part 3. What we're going to do in this video is graph the exponential function by the mapping rule. So notice we have y equals 3, bracket, the base is in 2, power is x minus 1 plus 1. So we're going to graph by the mapping rule, so y equals 2 to the x is the basic equation. The base is 2, so the base is 2, so we just have y equals 2 to the x. When we do, we put x and y into this table, so this is y equals 2 to the x. So we'll go 2, 1, 0, negative 1, negative 2 for this basic graph. X is 2, 2 squared is 4, x is 1, 2 to the 1 is 2, x is 0, 2 to the 0 is 1, x is negative 1, which is 1 over 2, x to the negative 2 is 1 over 2 squared, which is 1/4. So, if we have, now we have to do the mapping rule. So the mapping rule, what we'll do, the mapping rule is x comma y. And we get the, notice we have a 1 here, so x is 1, 1x, but we have to get the opposite of a minus 1, which is a plus 1. So that's the value of x that we're going to use to do the mapping, x plus 1. We get the reciprocal of 1, which is 1, but we don't need it, it's just 1 there. Now we'll do the y, so it's a 3 times 3y plus 1. Remember in the previous video we practiced how to write the mapping rule. So now we're going to use this mapping rule. So the new x coordinates are x plus 1. The new y coordinates are 3y plus 1. So we take these x coordinates and we plug them in here. X is 2. So x plus 1 is 3. X is 1. 1 plus 1 is 2. X is 0. Add 1 on. We get a 1. So notice these x values is 1 more, so that's going to be a 0, and that's going to be negative 1. Again, negative 1 subbed in here will give me a 0. Negative 2 subbed in will give me negative 1. Now we're going to take the x values belonging to the basic graph and plug in here. So notice the y value is tripled and then added on 1. So 4 subbed in. 3 times 4 is 12, plus 1 is 13. We're going to sub 2 in. 3 times 2 is 6, plus 1 is 7. We're going to sub 1 in. 3 times 1, 3 plus 1 is 4. Sub a half in. So 3 times a half is 3 over 2, plus 1 is 3 over 2 is 1 1/2, so that's 2 1/2. Sub 1/4 in. 3 times 1/4 is 3/4 plus 1 is 1 3/4. So now we'll plot these points. So when x is 3, y is 13. X is 3, 13 is, let's say, way up here. When x is 2, y is 7. X is 2, y is 7, right here. X is 1, y is 4. X is 1, y is 4. X is 0, y is 2 1/2. X is 0, 2 1/2. When x is negative 1, y is 1 3/4. Negative 1 is 1 3/4. So there's negative 1, so there's 2, so 1 3/4 is about there. So what happens if we need to do more? If we want to see, if we put a negative 3 in, negative 3 will give me 2 to the negative 3 is 1/8, and a negative 3 here will give me negative 2. And we plug a 1/8 into here, we give me 3/8, give me 1 3/8. So we plug in negative 2, we get 1 3/8. Just there's 1, so it's a little bit higher than 1. So notice that the plus 1 here, so that's going to be an asymptote. So it's getting, if you draw the graph, there it is. Notice it's a growth curve because the base is 2. And it's going to come along here, but it's coming along by where x is 1. sorry, where y equals 1 is the asymptote, cutting through y equals 1, not x is 1 here, y equals 1. So the graph is going like that. So notice it's going towards 1. As x gets larger and larger and larger, y gets closer and closer to 1. So the asymptote is y equals 1. Okay, let's graph another one. Graph each by the mapping rule. So we have this function. So again, we have y equals, the base is 3, so it's 3 to the x. And the mapping rule is x comma y. And let's look at the values of x. We have a half x and nothing else. So we have to get the reciprocal of that, which is 2. So it's a 2x. And the y value is, that's a negative 1, negative y minus 1, negative y minus 1. So we have a table of values of x and y, so we go 2, 1, 0, negative 1, negative 2. Because of the 3, 3 squared is 9, 3 to the 1 is 3, 3 to the 0 is 1, 3 to the negative 1 is 1/3, 3 to the negative 2 is 1/9. Notice in all basic y equals b to the x, so no matter what equation you have, y equals b to the x, notice that when you let x equals 0, y is always 1. That's what we call the focal point. That's where the graph cuts the y-axis. That's true for all equations like y equals b to the x, because b is always greater than 0 and never 1. So the y-intercept for this basic equation, like y equals b to the x, is always 0, 1. So now we put a 2x here, and we put a negative y minus 1 here. So we take 2, sub in, 4, 1, sub in, 2. Put 0 in, we get a 0. Put a negative 1 in, we get a negative 2. Put negative 2 in, we get a negative 4. And we sub in 9 here, negative y is 9, so negative 9 minus 1 is negative 10. Sub in 3, we get a negative 3 minus 1 is negative 4. Sub in 1, negative 1 minus 1 is negative 2. Sub in 1/3, negative 1/3 minus 1 is negative 1 1/3. Sub in 1/9, it's a negative 1/9, so it's a negative 1 1/9. And again, just look, as you can see by the equation, that the asymptote is a minus 1, which means this graph is moved down 1. So let's graph this. X is 4, which is here. Y is negative 10. It's 4 is negative 10. X is 2, y is negative 4. X is 2, y is negative 4. X is 0, y is negative 2. X is negative 2, y is negative 1 1/3. So there's negative 2, negative 1 1/3. It stays about right there. And a negative 4 is a negative 1 1/9. Negative 4 is a negative 1 1/9. And it stays right there. Notice it's closer. The asymptote is a negative 1. So if I draw a dotted line indicating that's the asymptote, so the asymptote is y equals negative 1. And so notice that this is negative. This is a negative here. So that means it's reflected in the x-axis. So the curve is doing this. So remember, this is 3, which is a growth curve. A growth curve goes, growth curve goes like this. So when it's reflected, it's now doing this. And it gets closer and closer, but won't touch. So there's the graph of this function using the mapping rule. Again, I want to emphasize, this number here is the asymptote. And because this is the asymptote of a negative 1, it's going down. So the range is, so if we look at the range here, the range would be y is less than negative 1. It's down below. Again, the asymptote is negative 1, and it's going down, so that's why it's less than. Let's continue and try another one. graph each by the mapping rule. And again, the basic equation is y equals, the base is a half, so it's a half to the x. So the mapping rule is x comma y. Here we go. And the x, we get the reciprocal of -2, which is a negative a half, x, and the opposite of +1, which is a -1. When we do the y, there's a 1 here, so it's a 1y minus 3. So it's a y minus 3. Again, in terms of the x, you get the reciprocal of this one, and you get the opposite of this one. And that's the mapping rule. So this is x, y. So when x is 2, 1, 0, -1, -2, we get 2 to the half is 1/4. 2 to the 1 is 1/2. 2 to the 0 is 1. Sorry, 1/2 to the 1 is 1/2. 1/2 to the 0 is 1. 1/2 to the -1. So we took 1/2 and raised it to the -1. We get the negative exponent, gets the reciprocal of 1, so it just becomes 2. So we get 1/2 to the -2. Reciprocal of a half is 2, so 2 squared is 4. So that's the table of values for the basic. So we take -1/2 x minus 1, and y is -3. So we take these values, sub it in. Sub in a 2. 2 in the place of x. -1/2 times 2 is -1 minus 1 is -2. Put 1 in. 1 times a half is -1/2 minus 1 is -1.5. And we sub in 0, we get -1. We put in a -1 in here, we get a +1/2 minus 1, which is a -1/2. And we put in a -2. -1/2 times -2 is 1. That gives us a 0. So now we put in 1/4 in. 1/4 minus 3, it's a -2 3/4. 1/2 minus 3 is a -2 1/2. And we put in a 1. 1 minus 3 is -2. And we put in a -1. We put in, put in 2. So I put the 1 in, I got a -2, put the 2 in, 2 minus 3 is -1, put the 4 in, and I get a 1. So we take each of these values, sub them into this expression, and this comes out, and we draw the graph. Again, notice the asymptote is a -3. So the asymptote is a -3, so because I'm used to it, and I know that this graph is going to go towards this asymptote. This is the asymptote on the end. Y equals -3. And notice that this graph is not negative. That's positive. So that means this graph is going to go up from here. Okay, let's go. X is -2, which is right here. Y is a -2 3/4. So there's -3. So there's -2 3/4. X is -1.5, which is here. Y is 2.5, so it's right here. X is -1. Y is -2. X is -1. Y is -2. X is -1/2, which is right here. Y is -1. X is 0. Y is 1. When x is 0, y is 1. So it's notice they're all put together. That's because, notice this is a 2. So that means that the space between the x is only 1/2, because it's always the reciprocal. So it's a half, but it's negative. So there's the asymptote. So here's what is happening. Like that. And to check it out, if you want, take a 1 and plug it in to see what you're going to get. So if you take x to be 1 and plug it in. So if you plug 1 in here, you get a half. I'm subbing in 1 now. So I get a half, -2, 2, I get a half, negative 4. A half to a negative, so that's 2 to the 4th. 16 minus 3 is 13. So notice the half to the negative 4 power. Negative flips the fraction to a 2. This becomes positive. So that's a 16 minus 3. So if you had 1, you would have it would go on up through 13 way up there. So we notice the graph is going okay. Again, that's the asymptote. But notice the range. I say ranges are. The range is in relation to the asymptote, negative 3 is greater because its positive is going up. Okay, let's try another one. And you should know how to handle it by the pattern I'm creating. A graph with this y equals negative 3, bracket 1/3 base to the x plus 2. So the basic equation, the base is 1/3, so it's 1/3 to the x. So this is x, y, so it's 2, 1, 0, negative 1, negative 2. 1/3 squared is 1/9, and 1/3 to the 1 is 1/3, 1/3 to the 0 is 1, 1/3 to the negative 1 flips it, 3 to the 1, 3, and 1/3 to the negative 2 flips it, 3 squared is 9. And we can graph that if we want. But the basic graph, notice, is a decay. A decay means it's going to come like that. But with this mapping rule, this is the transformations on this. So the mapping rule says we have an x comma y. And what's happening to it? Well, the x is just, that's a 1, so it's just an x minus 2. It's the opposite. The reciprocal of 1 is 1, so we just got a minus 2. The y is going to be negative 3 times y, and there's a 0 here. So this is a negative 3y, and a 0 on the end. So the asymptote is 0. So this is the asymptote through here. This is your asymptote. And the asymptote is y equals 0. And because it's negative, I know that the graph is going to be down here. Okay, here we go. We got an x minus 2. We got a negative 3y. Take 2, plug it in, we get a 0. Take 1, sub it in, we get a negative 1. Put in a 0, we get negative 2. Now it's going down. So that should be, if you obey the pattern, that's a 0, negative 1, so it's going down by 1. Just check. Put a negative 2 in here, negative 2 minus 2. Perfect. Now we're going negative 3 times y. 1/9 times negative 3 is negative 1/3. 1/3 times negative 3 is negative 1. 1 times negative 3 is negative 3. 3 times negative 3 is negative 9. Negative 3 times 9 is a negative 27. So when x is 0, right here, y is a negative 1/3. So that's right there. When x is negative 1, y is negative 1. When x is negative 1, y is negative 1. Again, this is the asymptote, so it's when x is negative 2, y is negative 3. When x is negative 2, y is negative 3. When x is negative 3, y is negative 9. Negative 3, negative 9. Okay, let's say it's right here. And when x is negative 4, y is negative 27, so that is way down here. So you can see that she's curving like this, coming on down, down, down. So that means if it's going like that, it has to come up, and there's the asymptote. It goes in here. And so the asymptote is y equals 0, and the range is y is less than 0, because it's down below, because it's negative, it's going down. And notice I didn't mention domain. The domain is always the real numbers. The domain is always x belongs to R for any exponential function of what? Y equals b to the x. All graphs like this will have the x values are reals. So that's how to graph using a mapping rule. And if you didn't use a mapping rule, you could think about it. What value of x would you put in here to give you 0? So you put negative 2. So a negative 2 going in this equation, negative 2 will work out to be a negative 3. So then you can take values to the right of that, 2 of them, and values to the left of that, 2 of them. That's another way you can also grab. But the mapping rule is good to know. Okay, that brings us to the end. And if you like my video, click the like button. If you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.